Hello everybody. We are doing the last part of this review guide. This is the actual graphing part where we have to do stuff like find the vertex, graph a big ol' U-shape for quadratic, and the last question of it is to summarize translations and stuff. So, first thing we're going to do is trying to find the vertex of this thing. So it is not in vertex form. So you could either do something like completing the square to put it in vertex form, but that is a lot more work than using the vertex formula. So I'm just going to do that. If you have not memorized it, memorize it. It is negative b over 2a. And that is just a simple formula. Negative b over 2a will be equal to a number. And whatever number you get goes right here in this first space for the vertex. So we'll start with that. It looks like a is 2, b is negative 4, and c is 3. So negative b. B is negative 4, so negative b is going to be positive 4 over 2 times a, which is 2. So you get 4 over 4, which is equal to 1. And as I said, that number is going to be the first number of the vertex. Since this is an x value, the way you can find a y value given an x is to take this number and plug it in for x. So this one is being plugged in for x and x right there. So you'd get 2 times 1 squared minus 4 times 1 plus 3. Plugging in 1 for x. Do make sure you follow PEMDAS. You do have to square this number first. Don't try to multiply because PEMDAS, it's parentheses and then exponents. So 1 squared is 1, and then 1 times 2 is 2. 4 times 1 is just 4 plus 3. Then 2 minus 4 is negative 2 plus 3, and you just get another 1. So in this case, it turns out to be 1 again. So the vertex is at 1, 1. And I'm just going to go ahead and plot that right there. You now have 2 options in order to find the next point. Now, just because it comes up in other problems, I'm just going to go ahead and say, well, this number right here is the y-intercept. We talked about in class that for a y-intercept, you make x equal to 0. But if x is 0, this is just 0, this is just 0, and the only thing you have left is 3. So y-intercept would be 0, 3. And you could plot that point, 0, 3, right there. Which, this actually gives you 2 points, because you know this is the vertex, so it's got to go like that, but since it is always 100% a U-shape, you can reason out that if there's a point here, there's got to be a point there. And now you have 3 points that you can make a U. The other way you could have done it is that since this is a whole number in front, this trick only works if it's a whole number in front. But if it is a whole number in front, you could have used it as a sort of slope. It's not actually slope, but could have, somewhat. You could go up to and over 1. That only works once. You couldn't do it again. If you put a point here, you're starting to make a v, which is an absolute value instead of a quadratic. But if you use those 3 things to find, and then just make a U shape, that would be correct. Okay, the max min, this faces up. This means this right here is going to be a minimum. So it's going to be a minimum, and the minimum always happens there. Well, I guess the way it's asking it wants you to put minimum here, and the value there would be 1, 1, the vertex. Axis of symmetry is x equals. Well, if you were to kind of draw it, it would look like this. And that number right there is 1. And since it's on the x-axis, that's why it says x equals. This is where x equals 1. Domain is always going to be all real numbers. So you can put all real numbers, or you can put negative infinity to infinity, whichever. And range, the lowest it gets is this number right here, which is a 1. And the highest it gets is infinity. Infinities are always a parenthesis, and since this is a whole, actually their point, it's going to be with a bracket. Okay, and that's the entire first problem right there. The next one, well, this one is in vertex form, so it's going to go a little bit faster. Since it's in vertex form, if you ever see something in parentheses, you do its opposite. So this would actually be negative 2. This is not in parentheses, so you don't switch it. You just get another minus 2. So minus 2, minus 2. No formula needed. It's in vertex form. So please know the difference between those two. This is in vertex form because it has something squared minus something or plus something. The other one was a squared b squared plus, ax squared plus bx plus c. This is not like that. This is vertex form. It's a lot easier because you can just go ahead and plot the vertex. Once again, we kind of luck out since this is a -2. -2 is an integer, The negative just means it's going to go down. The 2 right here being a whole number means you could use it as a slope. So you could go down to and over 1 for 1 point and 1 point only. That only works once, though. Other thing you could have done was something like find the y-intercept. If you find the y-intercept, then once again, the way you find y-intercept is by making x 0. So you would have -2 times 0 plus 2 squared minus 2. So you plug in 0 for x. Order of operations, say you would do 2 squared, which is 4. And then 4 times -2 is -8. So it looks like this would just barely be on the graph down here. This is -6, -7, -8, -9, -10, right there. Which you could once again just kind of reflect over here to show that there would be a point there. And you could get those points to make a U. Now, you only need 3. I'm just showing you different ways you could have gotten it. Okay. Next up, max min. This time it opens down, which means this right here will be a maximum. There is a top. So I would put max. And the value there is -2. -2 again, always the vertex. Axis of symmetry is right here, which means it's going through -2. Domain goes left forever and right forever, so once again, eigenvalue to infinity or all real numbers, whichever. And range, the lowest it gets here is -infinity. And the highest it gets is right here. And that highest is -2 with a bracket. All right. There you go, entire problem. Last up, it says to summarize the translation, or transformation, I think is what it should say. Transformation. Translation is just one type of transformation. What I suggest you do is you look at the equation and then start talking about them. Because sometimes people will try to say, oh yeah, what's that thing with translation? Let's talk about it. Oh, what's that thing with reflection? Let's talk about it. Stretches, shrinks, let's talk about it. But really, it's easiest to look at the equation first and say, well, I see this negative sign. What does it do? That's the thing where it makes it open down. Don't think about math yet. Think about just what these things are supposed to do. This 3/4 right here, what does that do? Well, that's the thing that's tells you how much wider it gets or how much steeper it gets. So, it gets wider or steeper. In this case, it would get wider because 3/4 is less than 1, right? The negative just meant it opened down, but the 3/4, the number itself, means it's going to get wider. And then these, -4 plus 1, that tells you where the vertex is. And just as a note, it would be at 4, 1, because you change the minus to a plus, and that just stays the same. And now you can start writing what these actually mean in math terms. Opening down, that's called a reflection. Reflects across on the x-axis. So that's the first thing we're going to talk about. The second thing, the whole getting wider thing. Depending on what math class you're in, it's called different things. This class, we are calling it a compression, that's right. You also hear it called a shrink, but this one's called a compression. Synonyms. Okay, so that's that one. And then vertex, we call the translations. And that's just what directions it goes. Since this is 4, 1, you would go 4 to the right and 1 up. Right and up. And there you go. That's everything there is. So there you go. End of the review. Yay. Have a good one and good luck on the test. Peace out.